Hi guys, and welcome back to my channel. So today I would like to talk to you about how we can build serverless functions. Of course, still using Rust, and this is not in any way limited to Rust. We can still do this with Go or whichever other language of choice we would prefer. But the interesting thing in this video is that I would like us, of course, to do this in Rust because I would like us in the end to compile our application to WebAssembly. If you do not already know what WebAssembly is, maybe I can just tell you something real quick about WebAssembly. So WebAssembly is a low-level binary format, a more or less language defined for designed for efficient execution in web browsers specifically. So you can think of it actually as a virtual machine that runs code compiled from several programming languages like Rust, like Python, like Go, like JavaScript, which was also why I said we can actually do this in any language of choice. But again, for this video, we'll be sticking to Rust. So some key characteristics of WebAssembly is that it's quite portable. It also gives you the flexibility, of course, to work with your language of choice. It's actually efficient because it's designed to be executed efficiently with performance comparable more or less to native code. Not quite as you would with native code, but it's quite comparable, I would say. So it also has offers like a sandbox execution environment, so giving you safety, and preventing you also from accessing or modifying host system memories or resources without explicit permissions. So the way it works actually is that you have your source code written in a supported programming language, which is then compiled to WebAssembly bytecode. And this then you have like a WebAssembly module which is loaded into the browser WebAssembly engine. And this again more or less helps you to, of course, validate and ensure that the code which you have adheres to the WASM specifications and is safe to be executed. And then the WASM engine goes ahead to also basically execute the code for you. So, but of course, in this tutorial, we will not be actually writing our code in WebAssembly. In case you're wondering, we'll write it in Rust and then compile it to WebAssembly. And in the end, when we have our code compiled, I would like to also introduce you to a cloud resource called the Fermyon Cloud that allows you more or less to deploy WebAssembly applications. So we're going to use this cloud to deploy our app, and then of course view this in the browser to see how it behaves. I know right now I might be feeling like a mouthful, but that's also totally fine. I'm gonna walk you through the process. We're gonna proceed in steps, and then hopefully achieve what we hope to achieve today. So up until this point, if you followed the tutorial series, I'm assuming you already have Rust installed locally. And the next thing we would need to install, of course, will be Spin. I have this already installed here. That's also why I've checked the version of what I have, and as you can see here, it actually says version 2.7. If you do not have this already installed, I will also leave a link. It's pretty straightforward to install, especially, for example, if you're on Windows, you can simply just download the binary and run this, and then, or more or less copy this to some place in your PC and then add this to path, and that's all. You're basically done. Okay, and again, one other thing I also wanted to let you understand is that with Fermyon, there are also a lot of templates that you can already work with, that people have been developing in the past, and you basically have the option to actually select from one of those templates to really start up quickly if you want. And what we can simply do here is I can say spin new. Again, I can maybe just show you. Of course, you have the option of going to help and then looking through all the different options you have here. Okay, so but what's interesting for us right now is to, again, you can, like I said, you have these templates that people have already written before, and you can check them out to see how you can actually get started. But for our own case, we are currently in a new, as you can see over here, I've created a new folder. It's completely empty. There's nothing in here. And to get started, I'm simply going to say spin new. And now you see some of the templates I already have installed. So I have a CRON Rust, which is basically like a CRON application written in Rust. And also have HTTP, which is a regular HTTP app for C and Zig. And some of you also have like Go. I don't know if you're familiar with Tiny Go, which basically, of course, allows you to write and compile WebAssembly, Go to WebAssembly, basically. And so there's PHP, there's Zig, and whatever the case might be. But for us, we would be focusing on Go. So I'm just gonna, but the way I would like to work is that I would like to be able to create a couple of um, apps, because of course you can think of these as serverless apps working independently of any other one within or together which they've been deployed. So we can write as many of the functions would like in here, and then we can deploy all of them together. And when we get deploy this, is going to just be one singular app on the Fermyon Cloud. Okay, so but to keep things simple, I'm just going to first go for HTTP empty. I'm going to give this a name. I'm also going to leave the name that's I already have up there called this Venv AI serverless, something like this. I'm not going to add description for now, and then that's it. So if you look in here, you would see basically two things. So why I also gave this the same name is because normally I would of course do this in a folder more or less, where I would like this of course to create a new folder for me. But that notwithstanding, I can simply just copy this and drag this to the root and then remove this guy. So the point for me is that if I expand this spin terminal, you would see like it simply just have all this information it asked of us, and that's it, nothing more here. There are no apps created. So now what we can actually do is I'm going to come up here again and I say spin add, and again I now have the option of actually adding a new app into my current project. So again, I'm just gonna maybe come down here and select HTTP Rust, this one, and I'll give it a name. I can call it API. I don't know, something like this. It's not gonna have. Maybe I say something like a simple test API in Rust, something like this. And path, I'm gonna maybe go to slash API, and that's it. So if you look over here right now, you would also see what's been added. And apart from what's been added here, we also have a new folder. And within that folder, it has to have the same name as what we have here as component. So if you look here, we have component and the name is also API. It has to match this, otherwise it will not be able to locate this file we try to compile. So, but if you look through this file, is a regular Rust project. So it has git ignore, it has cargo toml, which of course gonna help us more or less manage this app independently, like I told you. And then within here we have a simple librs. And the only interesting thing, of course, is that we have this function. We can actually be called anything, but the important thing is that it has to be annotated with this HTTP component. And within this point, we get to write on whatever piece of code we would like to write. So here I can say hello from the API serverless app, something like this. And that should be it. And maybe before we proceed, I would like to talk to you a little bit about this spin terminal. So basically, it's a regular TOML file, but the interesting thing is, of course, that it allows you the option to actually manage all the different apps you might have within this project. Um, so things like defining the trigger for a given app, and for that app, of course, defining the route and the component, which again is going to point us to the folder housing that app itself. And then regarding the component, which in this case is the API, is going to tell us, of course, something about the source. So when this is compiled, we will compile a WebAssembly 32 WASI, and inside of this folder would have a release folder, and then inside we'll have a file called api.wasm. So it's again just basically just pointing to where that WebAssembly file will be located when it's compiled. And allowed outbound hosts again really gives you the option to actually manage security. So it's exactly what it sounds like. It gives you the option to manage your outbound hosts. So you can really specify this if you want to add some layer of security to what you're doing. And then, of course, we have build. It basically defines how the project will be built. So in this case, it specifies it's for the components API, and the process is, of course, build, and the command is cargo build. Basically, builds for release, as you can see over here. Again, working directory is also where the code itself is located, and then watch is basically telling us, of course, the files to watch. In this case, is watching, of course, every file that's is of .rs is basically a ROS file. So that is actually what this is doing for us. So before we proceed, what you would of course need to do would be to go to the browser, to the Fermyon Cloud, and simply sign up. It's pretty straightforward. You can really sign up with your GitHub account, and it's going to look something like this. It's basically going to look something like this. So you just simply sign up, and then there are a lot of things you can read. You can go through some documentations, some examples, read through like the supported languages. If you look over here, you can actually see like you have like quite a list of what's supported. But again, for us, the interesting thing would be just Rust. As you can see over here, we are good to go. We don't have any limitations or any drawbacks at all. Because again, Rust WebAssembly for us was never an afterthought. It was there right from the get-go, basically. So you can just sign up and then get started. It's actually pretty straightforward. So, but just to also let you know, aside from um, basically just running serverless functions, you also have the option to also not just run this like a serverless function. You also have the option to actually integrate this to, let's say, your Kubernetes cluster. So if you want to run this, of course, within your Kubernetes setup, you also have the option of doing that basically. And if you look over, you can also see some of the tools, the open source tools that are currently being developed. And of course, to do this, you would have to work with SpinCube. But for now, I'm going to keep it simple. So we just focus on simple, straightforward serverless functions um, for us to simply get started. Okay, so at this point, what I can simply do, I have two options basically. I have the option, of course, deploying this straight to the cloud and just seeing what this looks like in the end. Or I also have the option of just running this locally to just see what's going on. And to do that is also pretty straightforward. I can simply say spin up, and now I seem to have some errors. So let me see. So basically, I have, of course, not. So if I come here and they spin help, you also see that I have the option of building the project, and currently I have actually not done that. So when I try to run the app, the error simply told me that the this path does not yet exist because of course the code has not been compiled. So you have the option of simply saying spin build, and this is just going to go ahead and compile the project like we discussed. And then in the end, we should be able to find a file named api.wasm. So if I simply go to API, in here, when this is done, would find this file that we are looking for. So I can just expand targets, and within targets, you can already see this. So I can go into WASM 32, and then in there I have release, and then inside of release I should now have my API WASM, as you can see over here. So our build is complete. I can now just collapse all of this, and now I can run the command again. So spin up, and we seem to have another error. It seems I have another app running at localhost 32, sorry, 3000. So let me see. I think I found the culprit. So anyways, I clear this out and I run this one last time. And now you can see what's defined here as available routes. So again, we defined this already. We said this app here has to be served on this endpoint, this route over here. And then if we go to the browser, I can also quickly show you that. It's pretty straightforward. So if we go to 127, so this one, and now you can also see we get our response back, so saying hello from the API serverless app. Pretty straightforward. So now when it comes to structure, you have the option of doing some fancy stuff. You can maybe come in here, create a folder called, I don't know, app, whatever, and then in here, you can now define a bunch of APIs depending on how you would want to do this. So here I have just a single API, but imagine you could drag this into this, for example, and then have multiple of these, and maybe doing the same different things for you basically. And then what you can now do in the end, of course, is to, of course, update the paths in here so that it's able to find specifically where those build files will be located in the end, and it should still work. So you now have the option of, let's say you are doing something like a ticket management service. So you can now do things like create an API for whatever the case might be, maybe for use management, for the ticket management itself. And of course, you also have the option of going inside here, coming to this API and basically managing the method. So here we can have request.method, and you can maybe actually match this value, for example, something like this. So you have the option of actually just maybe just cut this guy, bring it over here, and you have the option of doing something like this, so you can actually catch the difference, like HTTP verbs, or whatever the case might be. So, but that will not be the focus here. Of course, that's one way to go about it, but I would also like to show you some more different things about how we can actually have this all set up and up and running. But also, just to show you, we can also do something like this. I'm gonna stop all of this and remove this. And I can also do something like this spin build and then add the up flag to basically do those two things at a stretch. So we don't have to do them individually. So anyways, I'm going to maybe make this a little bit smaller and then expand these parts. And then in here, what I would like to do is maybe to add a new app. So I can say spin add, and then I would like to install, let's say, create an app with a template of this cron Rust. And so again, this is pretty straightforward. If you install Spin and you are not able to have exactly what I have here, is because you might be missing the required plugin. And I think maybe I terminate this. I say Spin help one more time, and I should have plugins. So I should have something like Spin plugins list or something. And here you can actually list all the plugins, for example, and then you get to decide the one that you require. And of course, the same, of course, is applicable to the templates. So if I say spin add, and you notice that you do not have any of the templates that I have here, it's basically because you have not installed that template. I'm also going to provide a link to like some of the templates that I'm familiar about that you can also install basically and then work with it. So I'll go with the first one by creating a Rust cron project, and I'm going to give it a name. I'm probably going to call it cron app. Description, I mean, be something like a simple cron app in Rust, whatever, doesn't really matter. And so this is a cron expression which we have encountered in the past. So if you're doing anything cron, you have to be familiar with cron expression. So, but basically what this will do for us is to run every 2 seconds. And I probably don't want that. Or so what I can do is, if I don't want to type this whole thing, I might probably just accept this and then update this later. That's totally fine. It's not a problem. So, but anyways, I'm just going to remove this guy here because I just use this for illustration. But the same way, we have a new folder now called cron app, but I can simply come in here and maybe differentiate all of this. I call this cron app. So this one would be API. I don't know. And now I can maybe change this to 30 so that this will run every 30 seconds. Okay. And now I can simply stop this and say spin build up. And then it's going to build, of course, the new project we've added, in this case, the cron app, just like it did for the previous one for us. And then after that, it will expose them both. But the interesting thing, of course, with cron functions is that they are not really something you trigger over HTTP. They are self-triggered basically. So they have a countdown timer that's basically times down what should happen. Let's say if, in our own case that we have this set to 30 seconds, it's basically just going to start counting down. So once it gets to 0, it's going to execute itself and updates the timer one more time. That's basically all it's going to do. So if I go here and again go to the librs, here is simply not doing much. It's simply saying hello from a CRON component, basically. And then it's simply injecting the timestamp that it was invoked. And that's also what you see down here. So if you look at it now, the next one would come at 271, which would definitely be 30 seconds from now. So if you look here, you see that another one got invoked, because again, what we did here was basically saying that we want to run this function located at these components within this folder every 30 seconds. That's really all you have to do. Again, serverless and completely independent from the other. We have the option to come in here and give this to another person in the team, for example, and this person completely goes ahead and develops this app, and independent of the other components of this app. And when we deploy this in the end, we'll still have basically one app on the Fermyon Cloud. But again, we will have several WebAssembly files that would be mapped to those logics. Again, depending if it is, let's say, HTTP triggered, when the incoming request comes in, it knows where to be mapped to and stuff like that. And then at this point, what we can simply do is I can say spin login, and this will allow me to log into the Fermyon Cloud. I can simply copy this on one-time code that you can see here on my terminal and go to this link. I'm going to open this, and maybe I'll bring this over once it opens so you can also see what I'm doing. It's taking a while, but I can only wait for it. So I bring this over here so you can see. So this is what was triggered from the terminal. I simply come here and paste the code I got from the terminal, and I click continue and I say authorize. And now it's been authorized. So if I come back in here, let me drop this here. So if I come back in here now, I see that I've been authorized. And what I can simply do at this point is to come here and say spin deploy. And that's really all we have to do. Once we hit deploy, it's just going to go ahead and deploy our app, and we can do all the things we can do here, basically. Nothing fancy. The only thing is it has different pricing options. And of course, I'm currently on a test option. So with that in mind, I cannot deploy CRON applications to the Fermyon Cloud. So if I should hit this now, I'm going to get an error saying non-HTTP triggers are not supported. So if I wanted to really deploy this to the cloud, to the Fermyon Cloud, basically all I need to do now is maybe to take this one out, and I should be able to deploy this one. So just wanted to let you know, in case you run into something like this, it's not because there is an error, it's just because of your pricing plan. So that's really it. So right now we've talked about just the basics, the introduction. And again, still part of the introduction, what I would like to show you next would be how we can work with environment variables. Again, this is pretty straightforward. So it shouldn't take us a lot of time to more or less set up. To add variables to our app is also quite straightforward. I'm probably just come down here and add a new section. I'm just going to call this variables. And then what I need to do is just come in here and say variables. And under these variables, I now get to define all my requests. So I can say something like API token, something like this. And of course, I have the option of going ahead and providing this token or having this provided from somewhere else. So I can have the option of adding additional um, requirements here, something like saying required true. And what this means is that I expect anybody using, of course, this app to basically provide this variable. And just because I've added this right now, if I should stop this and run this one more time, I'm going to get an error. And it's pretty straightforward. It says no provider resolved required variable API token, because this is simply not provided. So just because I did this, this will really not fall through. So I can also do something like maybe database, I don't know, URL. And again, I have the option of providing it like this, or again, doing something like I did initially. I also have the option of providing a default value. So if I provide a default value, I can say, I don't know, HTTPS, whatever, database, Let's come, I don't know, 5, 4, 3, 2, whatever, doesn't really matter. And then if I run this one more time, I'm still gonna get the same thing. So if you look here, it doesn't complain about the second one because the first one has was actually provided. So these variables are of course global to our setup. And of course, maybe I have to clarify this before we move forward. So to actually provide this variable is actually pretty straightforward. We have the option of actually providing this from the terminal. We can simply just add this from the CLI when we run this app like this. And to do that, of course, we can actually simply come here and say API token. Let's come here and I say API token and I give it a value. I see some boring token, and then I run my app. But the thing is, if I say run this, I'm still going to run into problems because for this to work, I have to actually prepend this um, with spin variable, something like this. And what is happening? Come on. What is this? Is it frozen? Oh shit, I'm just gonna shut this down. So now I can simply say spin variable like this, and then I say API token, and I give it a value. I can say some boring token like this. And now I can simply say spin build up. And this is fine one more time. So basically all we have needed to do was just to provide this in front of the, so this can actually be named anything. As you can see in our own case, we named it API token, but the interesting thing is that we needed to prepend this with this variable. But anyways, like I was saying before, these values are now actually global, but our apps actually do not have access to these variables. So to have them have access to this app again is also pretty straightforward. I can come in here and say components, and I specify the component, in this case API, and I can add variables to it specifically. I have the option of again directly adding this in here or even referencing the ones that are global. So here I can say something like token equal to, and I can actually inject this like this. Say API token like this, and then this would actually have access to the one we have up here. Pretty straightforward. And we also have the option of simply saying something like again, I'm gonna also do something like this. Okay, and now I can also maybe come here and say username Anthony. So I have the option of directly providing this way or basically referencing the one from the global. And then also now what I can also do for this cron app is to also provide if I actually need it to have access to these variables. And now for us to have access to this, since we are providing this to the API, I can simply go into the API app and come in here, and then within Spin, I'm going to bring in one more thing. So I'm probably just going to do it like, let me see, do it like this and bring this down and bring this down. And then in here, I can also request variables like this. And so this variables argument is basically just going to allow me to have access to these variables. So I can actually just come in here and say, let's token. So let token is going to be variables, and I simply call the get method and provide the name. And we named it API token. And that's basically it. And of course, it's going to return a result. So I can simply handle this like this. Again, I can say let db URL, say variable that gets and I provide it like this. Again, handle my error. And I can simply say, I can simply print all of this and say something like the token is something like this, pretty straightforward. And the database URL is, again, say db URL like this, pretty straightforward. And now, if we stop this again and run this app, and we should see our app come up one more time. But what I need to now do is to visit this point on the browser. So if I click on this, and that invokes this endpoint, and we also we run into an error saying no variable for API token. So again, I'm just gonna come in here and see it was actually called token. But anyways, I'm going to rename it to simply match that and restart this and refresh the browser one more time. And now we should get, they say the token is this and the database URL is this. Pretty straightforward. So that's about that. So to call your attention to this folder here called .spin. Inside of it is mostly where you would have things like spin logs, as that's maybe you might have already noticed with us running this application, or mostly, of course, when we develop locally. So you would see in this folder our logs, outputs and stuff like that. And as you can see, all of this coming in here. And this is always more or less tied to the individual app. So if I also go to the CRON app, you will also see that all the outputs we have here is also what actually gets logged in here. So just to call your attention to it, of course, that we have this in here, not just the logs. Aside from the logs, because of course with the Fermyon Cloud, when you're working with Spin locally and you're developing, you also have the option to work with databases, and not just locally but also within the Fermyon Cloud. So you can work with SQLite databases, you can work with a relational database, you can also work with a key value store. And I'm also going to show you all of that briefly in this tutorial, so you are also aware of those. But when we have those and we develop locally, would probably have a database locally that's also going to live within this .spin folder, like a database file, basically. So that's why I wanted to call your attention to it, to also have it on the look, to look out for it. Basically, it's not just spam; it's also for like coordinating basically what you're doing locally. Quite important. So let's proceed. I'm going to go back to the spin terminal, which basically helps to manage the entire setup. So I will go to our app, our API, and I would like to show you how you can actually work with a key value store. It's really, really straightforward. So I'm going to come in here under API, and I add a key value store. And for now, I'm just going to decide to work with the default key value store. So of course, I need to provide this as a string. And so once we have this set up, if I restart this, for example, if I restart this app that we have, you can see down here, for example, we get some warnings. Of course, that's no cause for panic. Would basically just talk a little bit about this and why we get this, and of course, tell you how you can actually get over it should you run into a problem like this. So if you run into an error like this, is pretty straightforward. It's first of all, what happens is that Spain tries to parse the TOML file, in this case the Spain TOML, and then it's going to tell you if there are any errors and why those errors are. So in our own case, we actually set key value store, but unfortunately, which also for me I found quite weird, was that this is actually expected to be an array. So instead of key value store, is actually named key value stores, as you can see from down here. So now we can simply replace this with stores and restart our server, and now everything should be fine one more time. So but the interesting thing now is, if you look at this file over here, we have login for the two apps we have. And now we also have a new file here called SQLite key value DB. And then again, if we look into Spin, we would have our in here. No, it should be in here. Maybe it's not created yet. But we will. Okay, I think this is going to actually get created once we try to use this for the first time. So that's why it's not created yet. But let's actually proceed and see how we can actually work with that. Again, it's also pretty straightforward in my opinion. To do that, all we have to do again is come down here. Everything is provided by the Spin SDK. So I'm going to come up here and say key value, and I need the store. Pretty straightforward like this. And now what I can actually do, again, we are doing so much in here, but that's also fine. Doesn't really matter. So what we can actually do here now is to define what we want to store. So we can store whatever we want to store, or whatever it is you would normally store with a key value store. And so not just strings, for example, or like quite simple things, we can also actually store structs. And I can also, maybe just to show you, I can create a simple struct here called user. And it's going to have some of the basic things a user can have. So we can have a username, which is going to be a string. It's going to be a last, maybe email, which is going to be a string, and it's going to be have an ID, which is going to be, let's say, I don't know, a string as well. Maybe let's make it a little bit interesting. Maybe let's make it not 1 Tony, but I64. And now what we can actually do is to try to store this value in our key value store, the one that we just created. And to do that, again, is also quite simple. So I'm going to come here at the comments and say working with this store. And then it's pretty straightforward. I'm going to create a store variable here, and this is going to come from our store. And I have the option of saying open default. Again, this is going to open a default store for me because in this case, I'm working locally. But again, I'm also going to show you how we can work with an actual store. That's so that when we deploy, of course, we also where we no longer have our Spin folder, for example, but we will now work with an actual resource on the Fermyon Cloud. It's also pretty straightforward. So in here, what we can simply do is to provide what we want to store. So I'm going to call this value, for example. So the value we want to store would be, of course, of type user. Pretty straightforward. So in here, I'm going to provide the simple things. Say username is going to be, I can say something like Anthony dot to string. Okay. And then email would be Tony at gmail.com, something like this. Again, I'm going to come back this to string. And last but not the least, ID, I'm just going to make this 1, something like this. So now we have, of course, I need to close this up. So now we have our value, and what we need to do now is to basically store this. So we can give it any key we want, and I can maybe simply, just to store this is pretty straightforward. I can say store dot, I have a lot of helper functions, and I can simply maybe call set JSON. I can simply call set JSON, for example. And then in here, I'm going to give this a key. So a key, I can call this admin. So I'm the admin. And value in this case, I need to pass this by reference and of course handle our error one more time. And we seem to have some error. Of course, this value needs to be serializable. So we need to, let me see if we already do. Let me see. Sorry, Kagutomo. We don't have set. So what we can simply do, of course, is to add Serde, because we should be able um to more or less serialize and deserialize our struct. So it's pretty straightforward. I'm going to say Serde, and then here I'm going to just pass some arguments. So version is going to be version 1. I'm going to keep it simple. Version 1. And features is, I'm just simply going to add a derive. And maybe I also go ahead and add setter JSON. So I say setter JSON. Also, it's going to be version 1.0. Maybe I also make this 1.0, something like this. Okay, so that now to our user struct, I can simply come in here and now add some traits to our user struct. So again, come over here and we say derive, and maybe I also leave debug in there, is fine. And then I add serialize. Come on, help me. This serialize. Let me see. And now, of course, I can simply come up here and say use cd. And now I pass serialize. And of course, I don't want to bring just that in. So I need serialize. Okay, and that's basically it. And of course, I always forget my semicolon, but that's also fine. So now once we have added these threads, it's now possible for us to, of course, call this set JSON, because it will require those functions to be able to serialize and deserialize our value to what we actually need to store in the end. And so what we can also do, maybe just to verify, is to say, I'm just call this let admin. And this admin, I'll simply say store, sorry, that's get JSON. And I pass a key again. It's going to be admin. And in here, I need to, of course, provide the type. So I'll say user. And what did I do? What is the error? Let's see. Consider expect get JSON. So store that get JSON. We handle the error. And I can also do maybe provide a context. What is that? Contexts, come on. And I can simply say something like user key not found, something like this. What is that? Key not found, something like this. And now I have my admin, and what I can actually do now is maybe just print this for verification purposes. So say the admin user is, I don't know, just that should be fine. And I pass my admin like this. And if everything goes well, we should be able to retrieve this value. Again, I'm just going to restart this one more time. And again, go to the web page. Let's see. Of course, we need to install the new package we added, or packages rather. And now I'm just going to go to, sorry, I'm just going to go to the web page. Or I can also just click this. And now you see over here, we are also able to store this value and also retrieve this from the database, from our key value store. And now, of course, if you look up here, you would see the database that was created for us. If you remember, it was not there initially because we never really used it, so it was never really created. That's fine. But again, one thing I wanted to show you also was, aside from doing this, maybe I can say maybe working with remote resource. What we can also do here is to simply say store.open, and I will use the open function. I will provide a label. So when you create these resources on the Fermyon Cloud, you always attach a label to them. So in this case, what you would need to do now is, of course, to provide that label here, and then everything should still work like we did before. It should still be pretty straightforward. So anyway, I'm going to comment this out. That's really all the change you need to do when you want to switch from working with the key value store locally to working with the one on the Fermyon Cloud. It's pretty straightforward as that. Okay, guys, let's proceed. So aside from working with our key value store, we can also just go ahead and work with SQLite databases. As you can already imagine, that is possible, and they would that should also be fine. So to work with SQLite databases, just like we did over there, and all we need to do is to come up here and say SQLite. I don't know if I wrote that quite well. So I say SQLite databases. Again, remember the problem we had initially. This has to be in plural, and now here I can also say default like this, and now we should be able to work with database within our apps locally. Again, if I restart this, we should still be fine if we type that out correctly. But again, it's also going to update us and tell us what's happening within the .spin folder, as you can also see up here. So we will have a file called sqlitedb.db. Again, this is going to be different from our key value store up here. So again, it's not yet created, but of course, when we'll try to work with this for the first time, it's going to be created again, and we'll be able to work with this. Again, the opening also works the same. We have the option of working with this locally, and also, of course, also have the option of working with this when we have this deployed to the Fermyon Cloud. So to work with this again is also pretty straightforward. I'm just going to come up here and say SQLite, as you can see. And now I can take things like this connection. For example, maybe I also take value. And then with these two imported variables, I now have the option, of course, working with my database. Also pretty straightforward. But anyways, I'm going to take this out because I don't want us to waste time and doing redundant stuff. So I'm just going to get rid of this to keep it as simple as possible. So what I would like us to do again is to, I'm like open a new terminal and call again the, use the CLI function again. Maybe I expand this a little bit so you see what I'm doing. So I say spin add. And now what I would like to do actually is to go to the bottom of the list where it says static file server and click on this. So the nice thing that this does for us is that we now also have the option to actually serve static content. So you can actually serve like HTML files with the CSS and JavaScript or whatever you would want to do. And this more or less can actually be like a quite interesting, fun way to maybe prototype something, to share something with your friends and all that. You can have like single page applications here, whatever the case might be. That's also quite interesting in my own opinion. So, but anyways, also the way we create is also quite similar to where you would any other of component or apps that we've been creating so far. So I'm just gonna give this a name. I'll probably call this file server, for example, and the endpoint where I want this to be is, or maybe I select the one that have been provided static, and I would have additional files in a folder called assets. So I'm also going to accept that, and then I can collapse all of this so we can actually look at what we have. So if you look at assets, it's completely empty. There's nothing inside of it. And if I come back to the spin terminal, maybe now I can bring this down. We also see that we have a new app for us created. So again, I'm going to maybe then this a little bit and call this file server. So the route is going to be at /static/everything. So basically everything in here can be matched. Okay, the component is called file server, and the for this file server, of course, we have additional attributes called here files, for example. And what it means is that we can actually go in here and provide additional files. And maybe actually I think I made a mistake, and what I'm gonna do is basically just copy this, come to these assets, rename it to file server like this. And then inside of here, I can now create a folder called assets. But in here, I can also create additional files. I can call this maybe index.html. And in here, I can write a simple HTML file with a header and and within here I'm gonna add a title and I say welcome to our Fermyon file server, something like this. And then in here we're gonna have a body. Within the body, I'm gonna have a P1 that says, H1 that says welcome, something like this, pretty straightforward. And that's all I'm going to do. And so what we can now actually do is to come back to this our spin toml. And now to clarify also a little bit what we have down here is that we've added a new component called file server. And that file server is going to be served at this route /static/wildcard. So it can be /static/ anything we want. Actually, I can also come in here, for example, maybe just to also show you, I can pull a picture from my downloads folder. Let me see. Downloads. Let me try to find an interesting picture. So I found this interesting picture and I'm just going to drop it in here. It's just a picture of me and some of my colleagues. And so what I can actually do is maybe I just rename this. I call this maybe Tony, something like this. Okay, so again, this is in the root, and what this means is that I actually now have the option of going to /static/tony.jpg. And I also now have the option to go to /static/index.html. But even if I don't specify this index.html, because this is a file server, when we go to simply.static, it's just going to look for this index.html. And if it is there, it's just going to render it. Okay, so what we can do now is basically test this out and see what's going to happen. So I'm just going to stop this for a second and restart our server one more time. And if everything goes well as expected, I can now go to the browser to actually see things for myself. And now I seem to have some error which I have to fix. So I have to also name this as file server because it needs to point to this, of course. And so let me try that one more time. Let me see. So spin up, and now it's actually up. And now you also see we have a new endpoint. It's named file server and it's being shown at this endpoint. I'm simply going to try to visit it. And maybe I bring this over here. And you also see we have an H1 here that simply says welcome. And that's also how we can actually solve this. Again, like I told you, we simply went to static. We have in there an index.html file and it's simply rendering that. So there is really no need for us to come in here and say something like index.html. It's exactly the same. The only thing we can actually do is now tony.jpg and it's going to serve that file for us. So that's also quite interesting, at least in my own opinion, that we get to also have, like, if we have built some interesting files or interesting apps I would also like to distribute, of course, we also have the option to serve this, which is also quite interesting because in the end, what would be deployed, of course, would be some with everything in any ways. The browser of course understands JavaScript and the likes, so we have the option of actually adding those in there and to make things a little bit interesting. So maybe one thing I can also show you to maybe we can decide how we want to wrap up would be I created a new file. I'm simply just going to drag this over. I'm just going to drag this in here. So I have this one called home. It's nothing fancy, just some drag and drop thingy that I did in the past. And maybe I get rid of this one now and bring in a new index file that I've also created. So again, it's another HTML file with a bunch of with some HCM, with some JavaScript and all that. So some fun thing I was doing on the side, and I just thought maybe it might also be interesting to share that with you. So again, nothing fancy. So I'm gonna restart this just to show you what's the content of these files are. Again, I'll bring this over. If you can see this, and then I go back to static, remove all of this, go back to static, and then this is what is actually in the home. So this is some fun drag and drop thingy I was just playing around with in the past, and I just thought of course maybe why not just show you this. And the other one is also quite similar. So home dots in the host dots HTML, I guess it was called. So this was also another type that I was playing around with, some drag and drop stuff. But again, just to show you that we can actually just serve static files, and this could actually pass for a simple SPA, a single page application, because if you look here, you can also see there is some HTML, there is some CSS, and some JavaScript, and you can already imagine what you could do. So just think about it. You have already access to key value stores, you have access to SQLite database, you also have access to relational database, you have access to running like serverless functions on demand, and you also have the option of actually serving a static or running a file server. Like there are actually limitless things you could actually do with all this combination, in my opinion. So what I would like to do now is to try to deploy all of this to the Fermyon Cloud, and then we can actually see how this behaves in the end. So I'm just going to come over to Spin Toml. Again, like I told you, we cannot run cron expressions for now on the Fermyon Cloud, also because of the plan we currently have. So I'm just commenting that out completely so the app itself would not be considered when we try to deploy this. And now what I can simply do is to come in here and now say Splin deploy. So it's going to take care of all the resources, the ones we also would like to create. We mentioned some key value store, and we also mentioned a SQLite database. And now we of course get an error, which is of course again similar to the one we had when we were running our application locally. So that's also not to panic. I'm just going to go come up here and copy these parts. Again, nothing fancy, and paste that in here, and now say spin deploy. And that's all we need to do to it seems we have which have not been set API token. Oh sorry, now we need to do spin build, sorry, deploy, and now use the variable flag. Variable, I don't remember if we have to, I think we can simply say API token, something like this. Don't remember. I think that's actually one way of doing it. So we basically use this locally, but of course, when we want to deploy, we use these variable flags to provide those variables. That's going to take a little while because also it will need to, of course, especially for this file server here, it will need to upload these files and everything. It will also has already compiled for the other apps that we have into WebAssembly. So it's going to, of course, now upload those WebAssembly files. So, but the interesting thing now is that we have two things here, two resources created. And now we also have the option of actually create a new database, as you can see here, or use an existing one. I would like to use an existing one because I think I already have one created. And so I'm going to use this one. And again, new key value store, I have created one before. So I'm going to also use this one that I created. And now is going to, so you have the option of also simply telling it to create a new one. It's going to create a new one for you. And then if you now go to the Fermyon Cloud, you also have the options of adjusting the label. So you can set the label also there, and then also have this referenced appropriately, more or less from within your application. So, but the interesting thing, of course, again, you see our app gets deployed and we get the URL. So I'm just gonna, I think this one is also interesting for me. So I'm just gonna copy this again and come open a new page. I'm gonna bring this over here so you can also see what I'm doing. and then I simply paste that one for the static and enter. And it's gonna take a while because I think that file is actually or maybe because you're actually invoking this for the first time, so it takes a while to actually get served. But after that, of course, again, we have our app. If you look here, of course, it's no longer running locally. This is running within the Fermyon Cloud. Okay. So what I can also do is to come in here. So go to the Fermyon Cloud, log in. I would log in, and you would also see the new app that we created. So if my internet is not so slow, now we are within the cloud, and then if I look here, you can also see the one I just created. You can also see it says created 1 minute ago. And so in within here, you now have the option of actually playing around with your resources, for example. So you have the option of coming in here, looking at your logs, you have your metrics, you have your domains. So maybe domain, I can even try to update this. I don't want this random variable that we got here, and I would like to call this maybe easy dev for all, and that's our new the new subdomain I want this to have. So it's going to be easy dev for all .fermyon.app, and what it also means now is I can actually just copy this, come back in here, and remove all of this and paste this here, and this should still serve our application. So I think it's gonna take a little while to update. Let me see. Let me copy this properly. I think I did. So, and then I go to static, and now of course it's live. So in my opinion, this is actually quite interesting. There's a lot more you can actually do with this. And then again, if I come to our key value store, like I was telling you, we have one now. We have the label here. It's actually called default, like we named it, and now it says linked to two apps because I didn't let it create a new one. I let it to link to the another one that I'm already using in a different app, and the same should also be for my SQLite database, more or less. And of course, you have app settings where you can now do things like say delete the app or stuff like that. Okay, so that's actually quite interesting in my opinion. There's really so much you can do with this. So again, I am also going to throw it open to you guys. So considering all I've shown you, all that's possible within this offering, especially when it pertains to building serverless applications in Rust and of course WebAssembly. We have like key value store, a SQLite database. We can run cron functions again locally, but not within the cloud because I'm using like a free plan. And all this, if there is anything you think we should do on this channel, again, with what I've shown you, what that's possible within this Fermyon Cloud, of course, within Rust, and then within building serverless applications, like anything you could think of that would basically take care of a specific task. If there's anything that comes to mind that you would like us to do in this channel, please feel free to let me know, and I promise you I will make a tutorial about that video and bring it to this channel. So anyway, guys, that's what will be really all. I can't really wait to hear what you guys are going to be building with this. There's so much more you can do. Again, it doesn't even need to be tied to this new resource that I showed you, because again, I'm not even doing some form of marketing. I just wanted to was really looking for some easy way you could really get started working with Rust and WebAssembly. But aside of this tool that I just mentioned, we can build full-fledged WebAssembly applications in Rust, and we can deploy it anywhere we want. So again, if that's also what you are interested in this channel, just go ahead and let me know and we'll make it happen. Anyway, guys, that will be all for now. And yeah, if you're new, go ahead and subscribe. If you have questions, hit me with those questions and I'll reply to you as fast as possible. And turn on the notification bell, get notified when we upload a new video. And yeah, feel free to reach out to me if anything is not clear. And yeah, guys, that will be all for now. And until we see each other next time, have a lovely evening, stay learning and stay safe, guys. Bye.